हेलो एवरीवन, वेलकम टू द लाइव सेशन। तो आज हम देखेंगे एनसीईआरटी ज्योग्राफी क्लास 11 का चैप्टर 11 वाटर इन द एटमॉस्फेयर। तो शुरू करते हैं। यू हैव ऑलरेडी लर्न दैट द एयर कंटेन्स वाटर वेपर. It varies from 0 to 4% by volume of atmosphere and plays an important role in the weather phenomena. Water is present in the atmosphere in three forms, namely gaseous, liquid and solid. The moisture in the atmosphere is derived from water bodies through evaporation and from plants through transpiration. Thus, there is a continuous exchange of water between the atmosphere, the ocean and the continents through the processes of evaporation, transpiration, condensation and precipitation. Water vapor present in the air is known as humidity. It is expressed quantitatively in different ways. The actual amount of the water vapor present in the atmosphere is known as the absolute humidity. It is the weight of water vapor per unit volume of air and is expressed in terms of grams per cubic meter. The ability of the air to hold water vapor depends entirely on its temperature. The absolute humidity differs from place to place on the surface of the earth. The percentage of moisture present in the atmosphere as compared to its full capacity at a given temperature is known as the relative humidity. With the change of air temperature, the capacity to retain moisture increases or decreases, and the relative humidity is also affected. It is greater over the ocean and least over the continents. The air containing moisture to its full capacity at a given temperature is said to be saturated. It means that the air at the given temperature is incapable of holding any additional amount of moisture at the stage. The temperature at which saturation occurs in a given sample of air is known as dew point. Evaporation and condensation. The amount of water vapor in atmosphere is added or withdrawn due to evaporation and condensation respectively. Evaporation is a process by which water is transferred from liquid to gaseous state. Heat is the main cause for the evaporation. The temperature at which the water starts evaporating is referred to as the latent heat of vaporization. Increase in temperature increases water absorption and retention capacity of the given parcel of air. Similarly, if the moisture content is low, air has a potentiality of absorbing and retaining moisture. Movement of air replaces the saturated layer with the unsaturated layer. Hence, the greater the movement of the air, the greater is the evaporation. The transformation of water vapor into water is called condensation. Condensation is caused by the loss of heat. When moist air is cooled, it may reach a level where its capacity to hold water vapor ceases. Then the excess water vapor condenses into liquid form. If it directly condenses into solid form, it is known as sublimation. In pre-air, condensation results from cooling around very small particles termed as hygroscopic condensation nuclei. Particles of dust, smoke, and salt from the ocean are particularly good nuclei because they absorb water. Condensation also takes place when the moist air comes in contact with some colder object, and it may also take place when the temperature is close to the dew point. Condensation therefore depends upon the amount of cooling and the relative humidity of the air. Condensation is influenced by the volume of air, temperature, pressure, and humidity. Condensation takes place when the temperature of the air is reduced to dew point with its volume remaining constant, when both the volume and temperature are reduced, when moisture is added to the air through evaporation. However, the most favorable condition for condensation is the decrease in air temperature. After condensation, the water vapor or the moisture in the atmosphere takes one of the following forms: dew, frost, fog, and clouds. Forms of condensation can be classified on the basis of temperature and location. Condensation takes place when the dew point is lower than the freezing point as well as higher than the freezing point. Dew. When the moisture is deposited in the form of water droplets on cooler surfaces of solid objects rather than nuclei in air above the surface, such as stones, grass, blades, and plant leaves. It is known as dew. The ideal conditions for its formation are clear sky, calm air, high relative humidity, and cold and long nights. For the formation of dew, it is necessary that the dew point is above the freezing point. Frost. Frost forms on cold surfaces when condensation takes place below freezing point 0 degrees Celsius. That means the dew point is at or below the freezing point. The excess moisture is deposited in the form of minute ice crystal instead of water droplets. The ideal conditions for the formation of white frost are the same as those for the formation of dew, except that the air temperature must be at or below the freezing point. Fog and mist. When the temperature of an air mass containing a large quantity of water vapor falls all of a sudden, condensation takes place within itself on fine dust particles. So, the fog is a cloud with its base at or very near to the ground. Because of the fog and mist, the visibility becomes 4 to 0. In urban and industrial centers, smoke provides plenty of nuclei which help the formation of fog and mist. Such a condition when fog is mixed with smoke is described as smog. The only difference between the mist and fog is that mist contains more moisture than the fog. In mist, each nuclei contains a thicker layer of moisture. Mists are frequent over mountains as the rising warm air of the slope meets a cold surface. Fogs are drier than the mist and they are prevalent where warm currents of air come in contact with cold currents. Fogs are mini clouds in which condensation takes place around nuclei provided by the dust, smoke, and the salt particles. Clouds. Cloud is a mass of minute water droplets or tiny crystals of ice formed by the condensation of the water vapor in free air at considerable elevations. As the clouds are formed at some height over the surface of the earth, they take various shapes. According to their height, expanse, density, and transparency or opaqueness, clouds are grouped under four types: cirrus, cumulus, stratus, and nimbus. Cirrus. Cirrus clouds are formed at a high altitude 8,000 to 12,000 meters. They are thin and detached clouds having a feathery appearance. They are always white in color. Cumulus. Cumulus clouds look like cotton wool. They are generally formed at height of 4,000 to 7,000 meters. They exist in patches and can be seen scattered here and there. They have a flat base. Stratus. As the name implies, these are clouds covering large portions of the sky. These clouds are generally formed either due to loss of heat or the mixing of air masses with different temperature. Nimbus. Nimbus clouds are black or dark grey. They form at middle levels or very near to the surface. Surface of the earth. These are extremely dense and opaque to the rays of the sun. Sometimes the clouds are so low that they seem to touch the ground. Nimbus clouds are shapeless masses of thick vapor. A combination of these four basic types can give rise to the following types of cloud: high clouds, cirrus, cirrostratus; cirrocumulus; middle clouds, altostratus and altocumulus; low clouds, stratocumulus and nimbostratus; and clouds with extensive vertical development, cumulus and cumulonimbus. Precipitation. The process of continuous condensation in free air helps the condensed particle to grow in size. When the resistance of the air falls to hold them against the force of gravity, they fall onto the earth's surface. So, after the condensation of water vapor, the release of moisture is known as precipitation. This may take place in liquid or solid form. The precipitation in the form of water is called rainfall. When the temperature is lower than 0 degrees Celsius, precipitation takes place in the form of fine flakes of snow and is called snowfall. Moisture is released in the form of hexagonal crystals. These crystals form flakes of snow. Besides rain and snow, other forms of precipitation are sleet and hail, though the latter are limited in occurrence and sporadic in both time and space. Sleet is frozen raindrops and refrozen melted snow water. When a layer of air with the temperature above freezing point overlies a sub-freezing layer near the ground, precipitation takes place in the form of sleet. Raindrops which leave the warmer air and come to the colder air below. As a result, they solidify and reach the ground as small pellets of ice not bigger than the raindrops from which they are formed. Sometimes drops of rain, after being released by the clouds, become solidified into small rounded solid pieces of ice and which reach the surface of the earth are called hailstones. These are formed by the rainwater passing through the colder layers. Hailstones have several concentric layers of ice one over the other. Types of rainfall. On the basis of origin, rainfall may be classified into three main types: the convectional, orographic or relief, and the cyclonic or frontal. Conventional rain. The air on being heated becomes light and rises up in convection currents. As it rises, it expands and loses heat, and consequently condensation takes place and cumulus clouds are formed. With thunder and lightning, heavy rainfall takes place, but this does not last long. Such rain is common in summer or in the hotter part of the day. It is very common in the equatorial regions and interior parts of the continents, particularly in the northern hemisphere. Orographic rain. When the saturated air mass comes across a mountain, it is forced to ascend, and as it rises, it expands. The temperature falls and the moisture is condensed. The chief characteristic of this sort of rain is that the windward slopes receive greater rainfall. After giving rain on the windward side, when this wind reaches the other slope, they descend and their temperature rises. Then their capacity to take in moisture increases, and hence these leeward slopes remain rainless and dry. The area situated on the leeward side which gets less rainfall is known as the rain shadow area. It is also known as the relief rain. Cyclonic rain. You have already read about extratropical cyclones and cyclonic rain in chapter 10. Please consult chapter 10 to understand cyclonic rainfall. World distribution of rainfall. Different parts on the Earth's surface receive different amounts of rainfall in a year, that too in different seasons. In general, as we proceed from the equator towards the poles, rainfall goes on decreasing steadily. The coastal areas of the world receive greater amounts of rainfall than the interior of the continents. The rainfall is more over the oceans than on the land masses of the world. Because of being great source of water, between the latitude 35 degree and 40 degree north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing towards the west. But between 45 degree and 65 degree north and south of the equator, due to the westerlies, the rainfall is first received on the western margins of the continents and it goes on decreasing towards the east. Wherever mountains run parallel to the coast, the rain is greater on the coastal plain on the windward side and it decreases toward the leeward side. On the basis of the total amount of annual precipitation, major precipitation regions of the world are identified as follows. The equatorial belt, the windward slopes of the mountains along the western coast in the cold temperature zone, and the coastal areas of the monsoon land receive heavy rainfall of over 200 cm per annum. Interior continental areas receive moderate rainfall varying from 100 to 200 cm per annum. The coastal area of the continent receive moderate amount of rainfall. The central parts of the tropical land and the eastern and interior parts of the temperate land receive rainfall varying between 50 to 100 cm per annum. Areas lying in rain shadow zone of the interior of the continents and high latitude receive very low rainfall, less than 50 cm per annum. Seasonal distribution of rainfall provides an important aspect to judge its effectiveness. In some regions, rainfall is distributed evenly throughout the year, such as in the equatorial belt and in the western parts of the cool temperate regions. तो ये था आज का हमारा चैप्टर. आप एक्सरसाइज कर सकते हैं. तो आज के लिए इतना ही. थैंक यू. थैंक्स फॉर ज्वाइनिंग.